So Sydney, this is going to help you again with, I'm just doing the parent function, okay? So you go around, and let me ask the question again, because it does not hurt to ask it again. Jordan, what is every x coordinate around the x, or around the unit circle? In general. Cosine theta. All right, and then Daniel, what is the y coordinate around the unit circle? Good job, it's sine theta. So when I'm ready to sketch this, I start with the quadrantal x values, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then I'm going to go around the circle, and I'm going to list the x coordinates. So that's going to go 1, 0, -1, 0, 1. So let's make sure we keep this straight. The sine curve begins and ends with the same, and its middle is the same. But in cosine, it starts and ends the same, but the middle isn't the same, okay? But so for both sine and cosine, they'll start and stop at the same y value. So let's plot this, and let's go 2 ticks is 1. So I'll have, oh, this is different now, okay? This is 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi. And then let's continue this going to the left, like this. So my amplitude is 1, the period is 2 pi, the domain is -infinity to infinity, and my range is -1 to 1. So let's write down a few little things. The amplitude is absolute value of A. Period is 2 pi over B. C is your phase shift, and D is your vertical shift, as long as that B value is factored out. If it's not, then you're going to have to take care of that. All right, in example 1, let me give you about a minute head start on me. And all I want you to do in example 1 is identify the amplitude, the period, the domain, range, phase shift, and vertical shift. Okay, try those. All right, here we go. So Jillian, what is the amplitude here? Good job, and it's a positive 2. Absolute value, it's a distance. All right, Becca, what is the period? Yeah, kind of weird looking, but 2 pi over 3. Jordan, what's the domain? Well, remember this oscillates forever. Yes. So for sine and cosine, the domain is always negative infinity to infinity because this will just keep oscillating. Okay? All right, now let me help you all with the range. Okay? Well, is there somebody who feels like pretty good about it and wants to share? Yeah, Wyatt, what'd you get? Yes, and we would, awesome, but we would put the 3 first. Okay, outstanding. So watch this. Here's how I do it. It normally starts negative 1 to 1. The amplitude would multiply by negative 2, but then I'd rearrange them. So that would be negative 2 to 2. And then I move it up 5. You see how you do that? Let me go through it one more time. To do the range without a graph, sine and cosine have a range of negative 1 to 1. You multiply by the amplitude, so that makes it negative 2 to 2, and then you use your vertical shift. What we learned yesterday is that's up 5. Yeah. Yeah. Yes. That works because you're taking it from 1, right? Yeah. Yeah, that works. All right. Lawrence, what would be the phase shift? Yeah, do you notice I gave it to you in the proper form? And then, Bella, what is the vertical shift? 5. All right. So now, let's take a look at example 2. It says we want to graph y equals negative 3 cosine 4x. So, Abby, what is the amplitude on that one? Example 2. 3. Good job. Good catch. Good catch. All right. Now, Daniel, what do we do to find the period? Yes. And what is the b value? Yeah. And so then Wyatt, what would that be when I reduce 2 pi over 4? Yeah. And then typically we just say pi over 2. Then Davy, what would be the domain? All right, and then Zoe, let's try and see if we can't figure this one out together. If I start with negative 1 to 1 and you multiply by the amplitude, what would the range be? Yeah, and you notice there's no phase shift or vertical shift. So here's what we're going to do. We're going to start with y equals cosine x. So you look at your teeny tiny little unit circle, and it goes 1, 0, negative 1, 0, 1. Then I'm going to change this to y equals negative 3 cosine 4x. And what you do is you go 0, and you put the period length at the end of the table. So that is 0 to pi over 2. All right, here's where it gets tricky. What's halfway between 0 and pi over 2? Pi over 4. All right, well, what's halfway between 0 and pi over 4? Pi over 8. Because our table, we want to get one period length. So the start is 0 and the end is the period. And we determined the period was pi over 2. Okay? Now, do you understand that once you get 0 to pi over 8, this means that each distance on the x-axis is pi over 8. So this is pi over 8, that's 2 pi over 8. Stop and think. 2 pi over 8 reduces to pi over 4. Then what's this one? 3 pi over 8, okay? And then, so that's 3 pi over 8. And then 4 pi over 8 would reduce to the pi over 2. Now what I'm doing, though, to the y values is you multiply by a. So instead of this being 1, it's going to be -3. And it's going to go -3, 0, +3, 0, -3. So I'm going to go by ones. And I'm going to go 0, -3. Uh-oh. Okay, do you understand? To get pi over 8, that's this little tick here. We're going to have to make little ticks for ourselves. So that's going to go 0. Pi over 4 goes up to 3. 3 pi over 8 is 0. And pi over 2 is back down to -3. Let's go ahead and continue this, because I think it's hard to see. Oh, so do you see if I went all the way to 2 pi, there would be 4 cycles? And b is 4. Remember we said there are b cycles in 2 pi. Yeah, go. Yeah. No, that's absolutely fine. Okay, so I'm going to blow this up a little bit. Okay. So here's the deal. Do you see this one is pi over 4? Yeah, and so then I had to make one to represent in my table pi over 8. See, I didn't have a tick for pi over 8, but it's halfway between 0 and pi over 4. This one would be 3 pi over 8. Remember in my table? Then, yeah, it's my table. All right, all right, we're going to go ahead and stop there, and then we're going to finish this tomorrow. The extra practice, you can get started on it, but let's clear off the desktop. You need something to write with. Yeah, it's no calculator.